Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is inverse of quadratic function. A quadratic function is nothing but a polynomial function with degree 2. The graph of the parabola will look like an U-shaped, either it would be open upwards or it would be open right or left. Now let us discuss how to find the inverse function of a quadratic function. What we want here is to find the inverse function, which implies that the inverse must be a function itself. Otherwise, we got an inverse that is not a function, which is not good. We all know that not all functions are naturally lucky to have inverse functions. This happens in the case of quadratics because they all fail the horizontal line test. However, if we restrict the domain to where the x values produce a graph that would pass the horizontal line test, then we will have an inverse function. But first, let's talk about the test which guarantees that the inverse is a function. It is called the horizontal line test. So what is meant by horizontal line test? Given a function f of x, it has an inverse denoted by the symbol f inverse of x. If no horizontal line intersects its graph more than one time, then we can say that the horizontal line test is passed, so that we can say that the function has an inverse. Okay, this is all about horizontal line test. Now let me show you key steps in finding the inverse function of a quadratic function. You would have been familiar with these steps because we are discussing a series of inverse of different kinds of functions. So some of the steps may be very similar to the other type of function. Okay, now let me give you the steps. As a first step, replace f of x by y. Switch the roles of x and y. In other words, we have to interchange x and y in the equation. And third step is solve for y in terms of x. We have to do this algebraically. You have to isolate y on one side of the equation and shift all the other terms including x on other side of the equation. After rewriting the equation in terms of y and solving for y, we have to replace y by f inverse of x to get the inverse function, and that would be the inverse function. Sometimes it is helpful to use the domain and range of the original function to identify the correct inverse function out of the two possibilities. This happens when you get a plus or minus case in the end. So when you're dealing with absolute value function, logarithmic function, exponential function, we used to take the graph of the given function and the inverse to check the answer is correct or not. But here for quadratic function, you have to consider the domain and range. Do you understand the difference between this step, checking the correct answer? Okay. These are the key steps to find the inverse of the quadratic function. Now let us discuss examples and apply these steps. Here is the first example. Please look at the question. X square plus 2. And no other information about this function is given. Am I right? So the first thing we realize is that this quadratic function does not have a restriction on its domain. Am I right? So I'm sure that when we graph this, we can draw a horizontal line that will intersect it more than once. Yes, because we don't have any restriction for the domain. Therefore, the inverse is not a function. So I will not even bother applying the key steps above to find its inverse, in case if the inverse is not existing. Let me show the graph of this function and explain you why this does not have an inverse. Even it is not a function. Do you see the graph of this function? X square plus 2. I'm drawing a horizontal line in red color. Do you notice that it touches the graph more than once? So the diagram shows that it fails the horizontal line test. Thus the inverse, even if we get an inverse by doing this algebraically, that is not going to be a function. So we can stop this example here because it will not have inverse function. Even if we solve it and get it algebraically, that is not going to be a function. Are you clear with this example? Okay. So first example has no restriction for the domain. Now I'm going to take one example where there is some restriction. Please look at this example. This is the same quadratic function as we seen in example 1, but it has a restriction on its domain, which is nothing but x greater than or equal to 0. So after plotting the function in xy axis, we can see that the graph is a parabola cut in half. for all x values equal to or greater than 0. Am I right? So this should pass the horizontal line test, which tells us that we can actually find its inverse function by following the suggested steps. I have drawn only the restricted domain. X square plus 2 greater than or equal to 0 means the right side, all the positive values. So here range would be y greater than or equal to 2 and domain would be x greater than or equal to 0. Am I right? So on this graph I clearly define the domain and range because I will need this information to help me identify the correct inverse function at the end. So whenever you're drawing the graph for the quadratic function, please mention the domain and range. In case if the domain is not restricted, you can check the graph and prove that the horizontal line test fails. But in this example, the restriction for domain is given. So you have to show the part only for the restricted area. And you have to mention the domain and range. Okay, please remember that domain and range of the inverse function comes from the range and domain of the original function respectively. Or we know that it is nothing but swapping of the domain and range. Am I right? Okay, now the graph has range y greater than or equal to 2 and domain x greater than or equal to 0. So even without solving for the inverse function, just yet we can easily identify its domain and range. I mean the domain and range of the inverse function using the information from the graph of the original function. So the domain for the inverse function would be x greater than or equal to 2 because we are just going to swap these information. And range for the inverse of the function would be y greater than or equal to 0. Do you all agree with me? Do you see how I interchange the domain and range of the original function to get the domain and range of its inverse? Yes, I'm just swapping. Now let's go ahead and solve algebraically to get the inverse of this function. Replace f of x by y. Interchange x and y. Now let's solve for y. So I'm going to subtract 2 from both the sides. I want to get rid of the square, so I'm taking square root on both the sides of the equation. Square root of y square would be y, and you have to keep a plus or minus sign before the square root of a quadratic function. Am I right? Replace y by f inverse of x. I'm going to write the answer separately for positive and negative. We get two cases due to the plus sign and minus sign. We have to pick this as the answer since its domain and range are opposite to the original function. Let me now graph the original function with its inverse in the same coordinate axis. So on the graph you can see the symmetric nature. Please look at the graph. I have drawn graph for the original function given and the inverse we found. If you draw a line here, you can see that they are symmetric to each other. Hope you are clear with this example. Okay, first example has no restriction for the domain, and the second example had restriction where all the terms, all the numbers are on the right side. Now I am going to take an example where the restriction is x less than or equal to 0. Okay, let me write the question on the board. Here is the next example. Please read the question carefully. We have a negative sign before the x square minus 1 and x is restricted to less than or equal to 0. This problem is very similar to the previous example. The range starts at y equal to -1 here and can down as low as possible. First, I'm going to graph this function, the original given function. I'm going to mention the domain and range for the graph of the function so that you can identify what would be the domain and range for the inverse, because we are just going to swap the information. Am I right? Okay, we are done with the graph. Now these are the steps on how to solve for the inverse. Apply square root operation results in getting two equations because of the positive and negative cases. To pick the correct inverse function out of the two, I suggest that you find the domain and range of each possible answer. That is the reason I have explained what is the domain and range for the given equation. So among the two answers, you can find the domain and range and compare it with the original function. So you have to pick the answer that would give the swapped information. Okay. The correct inverse function should have a domain coming from the range of the original function, the range coming from the domain of the same function. Do you all agree with me? Let's start doing this algebraically. Replace f of x by y. interchange x and y, add 1 on both the sides, divide both the sides by -1 because we have a negative sign before the y. We have to get rid of that. Take square root on both the sides. We always keep a positive and negative sign before the square root of a quadratic function. Am I right? Now rewrite y as f inverse of x. I'm going to write the answers separately as two cases. We get two cases due to the plus sign and minus sign. Okay, we can pick a final answer. When you compare the domain of these two cases, the domain and range is exact opposite of the original function is the second case, a -1. So this should be the inverse. Let me also show the graphs. So from the graph of the original function and its inverse on the same coordinate axis, you can draw a line and confirm that the symmetry condition satisfies. Hope you are clear with all the examples we discussed, and I think you got some idea, basic idea on finding the inverse of quadratic function. Still, we can discuss some examples that involves completing the square, and that would be the part 2 video on inverse of quadratic function. In case if you have any query, please let me know.